Hi, welcome to our math. Today I'm doing a series of videos on Gauss Jordan elimination. That's when you solve a system of equations using a matrix. Okay, so what I need to do first is I need to translate the system of equations into a matrix. A matrix is just generally a collection of numbers without the variables. So the coefficients for my first equation are 3/5 and -1/5. My constant number is a 9. For my second equation, I have 7/5 and 1/5 and an 11. All right, so what I want to do, first of all, I have no problem working with these numbers. I think they're quite glorious. I am all about fractions, but one of the nice things about matrices is if you are not in love with fractions, anything you do to the whole row is considered acceptable. So I can say row 1 times 5. I can say row 2 times 5. It's a little bit more easily seen in this kind of situation. If I multiply row 1 by 5, I'm going to end up with 3, -1, and 45. If I multiply row 2 by 5, I'm going to get a 7, 1, and 55. I'm still going to keep it as my augmented matrix. The augmented is the line that represents the equal sign. Now I can pivot on any of these numbers for clearing things out. What I'm trying to get is these four numbers, this left-hand side of the augmented matrix, into an identity matrix, which means I want ones along the diagonal and zeros everywhere else. I usually start at the top and work my way down, but it's such a treat. We have a 1 here, we have a -1 here. I'm going to start pivoting on this 1. That means I don't want to alter this second line. I only want to alter the first line. And the way I'm going to alter it is I'm going to say that this is row 1 with that -1 plus row 2, because what I want to do is I want that to be a 0. Oftentimes I'll pull rows out when I do things like adding, but that's usually when I have to multiply things. This time I'm just adding, and I'm adding into the top row. So 3 plus 7 is 10. -1 plus 1 is 0. 45 plus 55 is 100. And before I make this into a matrix, I'm going to do a quick divide by 10. That will give me 1, 0, 10, 7, 1, 55. We didn't change the second row at all. Now the beauty of this, of course, is we are one number away from having a perfect identity matrix. All we need is that 7 to be a 1. So what I'm going to do is I start with row 2, that's that 7, and to get that 1 to clear off the 7, what I need to do is I need to subtract 7 times row 1. Well, unlike here where I was just adding in line, this time I'm going to pull it out. So I'm going to come up here, and I usually do arrows because these get big and the arrows help the eye know where we're going step by step. Row 2 is going to be just that 7, 1, 55. -7, and I do the negative as well as anything else, because if you don't multiply through by the negative, if you subtract, you're bound to be adding by the end, which will not do you well, especially when we get to bigger matrices. All right, -7 times 1 is -7. Times 0 is 0, and times 10 is -70. When we add down, we get a 0. We get a 1, we get a -15. So that we now have 1, 0, 10, 0, 1, -15, augmented matrix. This literally translates to x equals 10, y equals -15. If I had to translate the augmented matrix back into a system of equations, that's what I would be left with. I always like to check my work to make sure everything worked out. Is 3/5 times 10 minus 1/5 times a -15 really equal to 9? 6 plus 3, yes, is 7/5 times 10 plus 1/5 times -15 really equal to 11? That's a 2, that's a 14 minus 3, that works too. So our answer as an ordered pair is 10, -15. I hope you've enjoyed this video. Please subscribe to my YouTube channel, like my Facebook page, and I'll see you on the next video. Thanks.